Hi, hello. Today we are looking regress 2PL. Okay, let's know what is 2PL. 2PL stands for two-phase locking and it is a concurrency control mechanism used in database management system to ensure the consistency and isolation of transactions. Concurrency control is crucial in multi-user database environment where multiple transactions may be executed concurrently. Two-phase locking consists of two phases. Let's look what is the two phases. Growing phase and shrinking phase. Growing phase in the two-phase locking protocol entails acquiring locks on the data items by transaction before it starts executing its operations. Shrinking phase. Shrinking phase in the two-phase locking protocol involves release of locks by a transaction occurring after it releases its first lock and leading to the final state either commit or abort. Let's look at the categories of 2PL. Strict 2PL. A transaction is not allowed to release any of its locks until it reaches the commit point. Ensures that no other transaction can be accessed the locked resources until the concurrent current transaction either commits or aborts. Cons- Conservative 2PL. A transaction occurs all the locks it needs at the beginning of its execution and hold them until completion. Permits the release of locking during the transaction's execution but prohibits the acquisition of new locks after the release. Regress 2PL. In regress two-phase locking, all locks are held till commit or abort. In this protocol, transactions can be serialized in order which they commit. Let's look in detail what is regress 2PL and let's see some examples of regress 2PL. Regress 2PL. Okay, um, I have given here some of the points about regress 2PL. Okay, let's look in the detail of regress 2PL. Here have we given that it guarantees that starvation cannot occur. That this means that no transaction will be identifiably prevented for making progress. And also it guarantees that deadlocks cannot occur. This means that two or more transactions cannot be mutually blocked, waiting each other to release locks. To achieve this guarantee, Regress 2PL enforces the following rules. Let's Before looking the rules, let's look the presentation. It requires that in addition to lock being two-phase, all exclusive is denoted by X and shared is denoted by S. Locks held by the transaction be released until after the transaction commits. We have looked at that guarantee the starvation cannot occur. Okay, next point is regress two-phase locking is even stricter. Here all locks are held till the commit or abort. In this protocol, transaction can be serialized in order in which they commit. Okay. Why should we have to achieve these guarantees? Let's look the following rules. Okay, that a transaction can occur locks in growing phase, and also a transaction can release locks in the shrinking phase. All locks are held until the transaction commits. In growing phase, the growing phase is the period during which a transaction occurs locks. During this phase, the transaction can only occur no locks. It cannot release any locks. In shrinking phase is the period during which a transaction releases the locks. During this phase, the transaction can only release existing locks. It cannot occur any low locks. Commits. When a transaction commits, all its locks are released. Let's see an example for regress 2PL. Okay, here is an example for regress 2PL. In this diagram, there is T1 and T2 accessing two resources A and B. T1 acquires a shared locks on A. We have seen and read A. Acquires an exclusive lock on B. T1 has B acquires an exclusive lock on B. Reads the B and then commit. And also T1 has been written the B and that thereafter T1 is commit. T2 acquired a shared lock. We have been seeing that there is a S lock of A. Okay. Shared lock and reads A and then it's commit and also shared locks B also has been shared locks. Okay. T1 acquires a shared lock A. T1 reads the A. Then thereafter T1 has been acquires a exclusive lock on B. Then T2 shared acquires a shared lock called A. Thereafter T2 reads the A. Then T1 has been committed. Then T1 locks its locks on B and T2 has been commit here and T2 release its lock on A. We have been seen here T1 has been lock on A and B. Here also T2 has been lock on A and B. Regress tuple is more restrictive form of tuple that requires all locks to be held until the transaction commits or aborts. This makes it more difficult to implement, but it also provides stronger guarantee about concurrency and consistency. Let's look some advantages and disadvantages of regress tuple. Advantages: enhance the consistency. A more rigorous approach to log management could contribute to higher level of data consistency, ensuring that transactions maintain the integrity of the database by preventing anomalies. Isolation assurance. Stricter rules on log acquisition and release may enhance the isolation of transaction, reducing the likelihood of interface or conflicts between concurrent transactions. Anomaly prevention. The additional constraints in Ergus tuple may help prevent specific anomalies such as cascading aborts, which can occur in less strict concurrency control protocols. Predictable behavior. With more rigid set of rules, transaction might exhibit more predictable behavior, making it easier to reason about the outcome of the concurrent operations. Okay. There are some disadvantages of regress tuple. Reduced concurrency. Stricter loop management may lead to increased contention of logs, potentially reducing the level of concurrency in the system and impacting overall performance. Complexity. Introducing additional rules for log acquisition and release could increase the complexity of the concurrency control mechanism, making the system harder to understand, implement, and maintain. Potential for deadlocks. Stricter protocols might increase the likelihood of deadlocks, especially if transactions are prevented from acquisition certain locks due to the rigid rules. Overhead. Enforcing a more rigorous protocol may introduce additional overhead in terms of processing time and resource utilization, potentially impact system efficiency. Difficulty in application development. Developers may find it more challenging to work within the constraints of rigorous protocol, and potentially leading in increased development time and effort. Okay. In the conclusion part, rigorous tuple is a speculative term suggesting a more strict version of two-phase locking protocol, which could ensure data consistency and isolation in systematic way. Rigorous tuple is a speculative term proposing a stricter version of two-phase locking protocol in database. This theoretical concept aims to enhance data consistency and isolation through more detailed constraints and rules. While not recognized term, its potentially adoption could depend on the formal definition acceptance in the database community and demonstrated effectiveness in managing concurrent transactions. I think that I hope that you all have understand this regress tuple and I will share this PPT to all of you. Thank you.